Okay, hello DevOps. Hi everybody. There's a lot of people working to get in, so if you've got a little room in there, squeeze in. Thank you all very, very, very much for coming, spending this 40 minutes to an hour to talk about containers and Kubernetes. So hi, I'm Brian, and you can get a hold of me on Twitter and Google+. And as a developer advocate, my job is to kind of help explain things and then hopefully enable you guys to build awesome stuff or help build awesome stuff. And then when you run into trouble using, for example, Google Cloud APIs because they're confusing or there's some bug, contact me and we'll try to bring that information back into the organization and make things better. So feedback loop job. Okay, so context setting. So Google is currently thinking about compute as this kind of spectrum. So on one end, we have, actually I'll start over here. We've got platform as a service kind of stuff. So if you're familiar with App Engine or Heroku, things like that, you basically write code, you deploy it up to a service somewhere, and they handle running as many copies as you need for the traffic you're actually getting. On the other side, we have virtual machines hosted on the internet. So you call up, you say, I want a computer that's this big with this many processors, this much RAM, that sort of thing. And you get a raw computer, you install an OS, maybe it comes installed Linux or Windows, and install all of your software on top of that. So you can do anything you want over there. Usually there's some constraints over here that allow the auto-scaling. And today, we're going to talk about this middle part, the cluster, like running, thinking about a whole data center as if it's one computer. So that's where we're at. And I'm going to refer back to this phrase over and over. It's not really the perfect phrase, but when we're trying to think of a whole cluster of computers, all as if they're one computer, like a data center as one computer, we need a distributed process manager. We need to be able to think about a systemd or an upstart-like thing, but that runs across a whole fleet of machines. So we'll keep that echoing back across. I'm going to kind of talk a little bit about what I think is a very common architecture, and then move on to Docker containers, how they change things in that world, and then on to Kubernetes and how that changes things even further. And then we'll wrap up. So here we are. Okay. So I don't know if you've read the highscalability.com blog. If you haven't, I highly recommend taking a look. They regularly do write-ups of common architectures for websites that get very, very large. And kind of, even if you're doing mobile, everything's a website these days because you've probably got an API behind the scenes as well. So if you kind of extract the key points out of all of these articles, there's almost always kind of front-end web servers of some sort. There's a database, which eventually becomes a bottleneck, probably. And then you've got a caching layer to help take some of that pressure off. And you probably have some batch processing. And then you can make this as complex as you want from there. Add more different kinds of batch processing, different versions of things, independent web servers, the whole bit. So we're going to kind of keep this in context as we're kind of working through some of the Docker conversations. But I think it's very common that we deploy these things each on their own machine. So the web servers might get their own machines, and maybe those machines are all the same, hopefully. But they're each on one machine. The caching, maybe that's on a different machine. The database, we definitely keep that in its own world so that nothing affects that, right? You've got back-end job processes and things like that. And there's a lot of reasons for this, but it's basically just easier and less risk, I think, is one of the primary drivers. In terms of managing these things, I've definitely done the world where you just manually set everything up and you have all your special Snowflake servers, and don't touch that one, it's delicate. Hopefully these days you're using something like Chef or Puppet, Salt, Ansible, one of these management systems that will kind of set up your environment for you and get things good to go. But that's definitely a lot of work. As far as the machines go, like we do development on all the computers, right? We're on our laptops, on computers that we own or our companies own, deploying things to the cloud, everywhere. But again, probably each different service to one machine. And even if you have your whole application automated, deployed everywhere, it's a huge challenge to kind of get this right and get it going that far. And then there's a whole bunch of things that that I think are kind of lurking out here. Part of the reason we keep things on separate machines is not just conflict on usage, but conflict of dependencies, right? Apologize here. I come from kind of the Python world, and in the Python world, dependency management has been an ongoing challenge. We kind of reinvent it every 3 or 4 years. And so you're constantly struggling with, oh yeah, I need this library. I want to make sure the context is all right, not a different version of it or what have you. And then because we're keeping things so separate, utilization is a challenge, right? So you scale your host machines up big enough that they can handle your peak load, and they're quiet, like almost all the time. And then when it comes to scaling, you've got a bunch of manual steps to do, things like that. Deploying new versions of things is challenging. You know, if you have to roll back, I don't even know. And out of curiosity, how many people in this room have a test environment that looks like your production environment? Ooh, there is a lot of work represented by those hands. That's a pretty high percent. I think that was like something like roughly a third. Super impressed. And I will submit, so check me on this by the end of the talk, but I'll submit that we can dramatically improve the situation managing all of these challenges using containers and Kubernetes. Okay, so containers. So first off, how many people here have heard of Docker, right? Everybody, hopefully. And how many people have actually started a container? Oh, nice. Okay, so probably about half the room. Even there, I think this is early days in kind of figuring out how all these pieces go together. And so I know I'm kind of a little confused about how things adapt all the time, and there's a lot of different options for how to work through all of these. It's a great time to be working with this, though. I think they're going to dramatically simplify all of our development lives. So I'm going to throw out just a few different ways to think about containers, or maybe if you're already totally down with containers and like know exactly what they are, different ways to try to help explain that to other people in your organization. So if you come from like a background where you worked with Solaris zones or jails on Linux, I think you can roughly say these are kind of like super-powered versions of Linux jails, things like that. Another way that you can talk about this, and this works especially well in kind of a business context or a high-level architectural context, is every time somebody says Docker or container or Kubernetes, just say microservices. Just be done with it, microservices. It's not completely right, but it's really close in terms of a lot of the benefits where things are going out. And my favorite is that these are just processes. We're all used to running processes on our computers, and these are just processes, but they're magic processes where the context and the environment goes with the process. So it sees the same execution environment wherever it runs. So just a little context, Google loves containers, completely loves containers. We submitted the early control groups stuff to the Linux kernel. We're actively participating in the development of the libcontainer abstraction around manages these things, and I won't talk about it today, but the new versions of App Engine can all run Docker containers, so you can run any language you like there. And Kubernetes is all in on containers. Yeah, I'll skip to that for later. And you may have heard in other Google Talks, we run almost everything in a container in production at Google. So we start something like 2 billion containers a week. It's like a big number, right? But we start like 2 billion processes a week. But they're all in containers. And I want to kind of like highlight a few things you get out of this. You get process isolation. So between the control groups and the namespacing, it's as if every process sees that it's got the computer all to itself. So it thinks it has its own kernel, it thinks it has its own file system, it thinks it can do whatever it wants, it can spin 100% proc and go crazy. But in actuality, it's kind of actually constrained down by these control groups, and it is allowed a specific amount of processor and a specific amount of network I/O, and can't go beyond that. And you can also set relative priorities between these things. So that's really powerful, and it dramatically reduces the risk of putting processes that might compete onto the same hosts. So process isolation is one concept. Another one, all throughout, is you can kind of imagine these as like static binaries. Do you remember static binaries? Like you write an app in C and you compile it, and then you just give the executable to somebody and it runs. You're just kind of done. Okay, well maybe all of your memories all of you don't have such fond memories of static binaries. But it's a kind of a great space to be, right? Where you can just send this potential process out to people, and it will just run. So static binaries also come with some big challenges, right? When you need to update the security libraries that they're using or what have you, in case there's some sort of bug, which never happens, right? I'm a little bit sarcastic, so if that comes out. So in a way, you can think of containers as giving you the best of both worlds of kind of static binaries, because you get this encapsulated runtime environment so that it runs the same way everywhere. And this is because of the file system work that Docker does, where it creates a file system out of layers of changes to the actual file system. And when it starts the container, that's the only thing the process sees. And any changes it makes are added to a new layer. So it always sees the same starting point, and it always sees the same context wherever it runs. And so this gives you kind of the benefit of like superpowered static binaries. And then if you do have, if one of your dependencies has an emergency fix, you're building these with a recipe, usually a Docker file. And so you can actually just go in and change the base image so that you're using the newest version, recreate your actual container image, your image. And then as long as you have a good way of pushing these out into production, you can just go and just replace it. You just stop the one and start the new one, and you're good to go. So best of both worlds, maybe. So awesome. Let's do containers everywhere, right? We'll just containerize everything. We'll run containers on all of our computers. Everything will live in a container. It'll be fantastic, right? Maybe a little hard. I hear some maybe not quite believe there. So we might run into some trouble with, like, how do we tell the containers where the other ones are, right? Like, our network starts to get really complex. How do they find each other? How do we keep them running? How do we keep a catalog of even what we have if we start creating thousands of containers across our machines? So we need a mechanism for handling that. And I'm going to come back to this distributed processor. Is like not distributed process manager is not quite the perfect word, but we'll go with it. And so this is exactly where we come to Kubernetes. And so Kubernetes is an open source project that comes out of Google, just released in, I believe, March of this year, or April. So it's very, very new, and it's moving very, very quickly. It's up on GitHub. It's like all the development happens out in the open. As an aside, if you've ever been curious like what a code review looks like at Google, like you can just go and look at the pull requests and see real work going on. And it's already become incredibly popular, and we're really, really excited about that. We've got lots of individual developers, lots of other companies working on this. And this project comes out of the 10 years of experience Google has developing container-based workloads and keeping them going over time. So this is a little quick update just to say, just things that have happened in the last week or so, a couple weeks. A new version released. We were up to 116 different contributors. If everybody in this room jumps in and files an issue or gives it a try, then we'll be way over that. So, and GitHub stars. And one of the things we're really, really excited about is that not only are individual developers diving in and playing with this, but also some very large organizations with lots of experience building distributed systems. So we've got some Google engineer experience baked in. We've got folks from CoreOS, HP, IBM. Mesos Sphere is implementing an API for Mesos that's Kubernetes compliant, or not compliant. It's the same API. It's a standard API. Microsoft already is doing stuff. Red Hat is doing all kinds of stuff. SaltStack, VMware, lots of others. And it's it's under very, very active development. We've got better scheduling and even better scheduling coming. Service model is changing a little bit, and I'll talk about that in a second. Some more logging and monitoring built in. And it's a new project when binary releases are a new feature. So we really think that when you move from thinking about containers running on one machine to running them across a whole fleet of machines, you need some extra abstractions to help keep that simple. Otherwise, you get a kind of a complexity explosion if you just try to think about it kind of the same way. And the core idea here, I think, is the difference between kind of imperative and declarative. So, with most systems, you come along and you say, okay, I want to run like 5 of these, and like go run 5. And then they come up and they run, and all is good until, like you're off having dinner or sleep or something, and then one of them crashes and the next one crashes. And then you have to go back and run 2 more on your phone or what have you. And Kubernetes kind of takes the inverse of that. Like you define, I want to be running 5 always. And it'll be like, oh, we start 5 of those up. And if one of them crashes, it'll be like, oh, that's not healthy anymore. Let's start a new one up, because it's constantly running a reconciliation between the declared state that you give and the actual state of the world. And it's always trying to make the world look like you've wanted it to be. So there's a few concepts that I'm going to run through to help keep things simple and easy to reason about as you start getting into having thousands and thousands of containers. But first, pardon me. Not what you needed to hear. Okay, so pods. Pods are one or more containers that kind of have a life cycle together. So very often, this is just one container. It might be a web front end or something like that. But you might need to run some kind of maintenance containers next to things, and they need to always run on the same machine. Or they need to do some work that is tightly related to each other. You've got a group of processes. So you can make individual containers and then wrap them up in this concept called a pod. And pods are the unit of scheduling in Kubernetes. And so they're just a group of containers. You make a template for these, say, okay, I want it based on this image. We'll see one in a moment. And it goes. Next up, we have labels. And labels are just key value pairs. But it's a concept kind of baked through the whole API. So when you create a pod, you can set arbitrary labels on it. And it's also how you query the system to say how many of these are running. You can ask questions like, give me the list of all the pods that are front ends in production. Or give me the list of all the pods that are running Redis in test. Things like that. Or whatever values you decide to set when you create them. And then based upon these labels, in terms of how the reconciliation actually works, we have this concept called replication controllers. And so when you push a template out to a replication controller, say, I want to run 3 copies of this pod. And Kubernetes will just pick a spot where there's space and run those. And then it will constantly run this reconciliation against the replication controller's template and the current state of things. And that's how it ends up working. And those are connected via labels. OK, so that's a lot of talking. It's demo time, live demo, network, clouds. It'd be awesome. OK. From previous experience, doing live demos with cloud services and poor network is a challenge. So we'll see how things go. Network's been awesome so far. Here we go. So we have I'm going to run all this against Google Cloud, but Google Cloud Platform. But all of this works against multiple different cloud providers, and including running it on your own machines. So I'm using gcloud, which is the command line tool as part of the Cloud SDK for Google, so you can deploy things to App Engine, create Compute Engine instances, and now run containers. So we're going to run this command that says replication controllers, create a replication controller based on this JSON file. So let's look at the JSON file real quick here. It's basically an ID, it's just a name, how many copies we want to run, the labels that it uses to figure out what's in that group, and an actual Docker image. So this is anything you have up on Docker Hub. And this, in my case, is, in fact, you can run this yourself. It's super exciting. This is a single image being served up by Nginx. That's a picture of a Nautilus. And if you don't know what a Nautilus is, or you're thinking of a different Nautilus than I might be thinking, we will see in a moment. So it serves that up. And then down below here, I have a web page that's just pulling the Kubernetes API and displaying a little bit of text, or a little box for each pod that's running. So in theory, if we run this, so that has sent the template up to the server, and boom, we're going. So that's exciting. Yay. Hey, I got some clapping. OK, so let's do something a little more worth clapping. So if we decide instead that this is a pretty big room, and even though we're stripping up static stuff, we actually want to have more instances running. So actually, I did that kind of fast. Sorry. Basically, I just changed replicas to 5 from 2. And then I've got this script that goes ahead and just removes the definition and then recreates it again there. So if we do this, we can be like, oh, we want to actually have 5 running. And boom. Yay. Ah. Thank you so much. That's amazing. But a lot of this is, it shows off the real power of containers here, right? Because these are just starting like processes. Most of this delay is actually, the web, polling and other stuff going on. And getting the messages around. The containers just start fast. So this is great. Okay, that's cool. But my boss is like, the internet's all about cats, not a lie. So I'm going to update this. I've got another container that I've built. Maybe it's output of my build system or what have you. And I'm gonna one-up him, not just do cats, but I'm going to do kittens. Kittens greater than cats, greater than not a lie, I think. And then we'll go ahead and update the configuration again. So this pushes out a new configuration. But you'll notice here that nothing really changed down below yet. So what the reconciliation is doing is actually looking at the number of containers running. And so there is a little tool that's part of Kubernetes that is called rolling update. And all it really does is it just goes and deletes one of the pods at a time and waits, in this case, 8 seconds between each one. So what you can do is, so if you're receiving traffic on your front end, you can go and then just drop and kind of go in and slowly knock off some of the older versions and replace them with newer versions. And then your service stays up the whole time, and users just transparently start seeing kittens instead of Nautilus. That's the plural of Nautilus, right? And so that's pretty cool. All I did was basically change which container that is and then go. The amazing thing to me is many systems are good at doing updates. But since this is just we're just changing which container we run, a rollback is exactly as easy. So if we want to go back to Nautilus, because it turns out they test better in A/B testing, then all I have to do is change the container back to the Nautilus container, and we're good to go. Exactly the same thing. And let's just go ahead and poke around at one of these. So we've got the Nautilus was running on, what is this, demo node 5. And now it's probably a kitten. So gcloud, compute, SSH, log into this particular node. And, oh, right. It is in Europe. Yeah, Compute Engine has regions all over the world. That was on purpose. So we log in here, and we're really on this machine. We can say Docker PS, see which things are actually running in Docker. Notice we're actually running cAdvisor to kind of start capturing some metrics, and over time, Kubernetes is going to do even more work balancing scheduling based on what's busy and things like that. But our kitten's running here. So if we were a really good ops guy, you'll be able to tell that I'm not here in a moment, we could just go ahead and kill one of these processes. So this could happen if I've got a bug in my kitten serving code or what have you. And so we go ahead and make that go away. It goes away. Kubernetes immediately notices that it's gone. And we get a new kitten. It might even be a clone of the same kitten. And we're good to go. So this resiliency is really powerful for sleeping at night and the like. And I think that's the moment where we go back to slides. Oh. OK, so what we just showed here is actually just kind of one part of this workload, right? This is just kind of like, imagine it being some front ends that do something more complicated than just serving an image off of Nginx. And these automatically get scheduled out onto host machines. So these are each running on compute engine hosts. And Kubernetes decides kind of where to put them, and they all happen. But pretty quickly, we can end up, even just with a few nodes and a few containers going, some fairly high complexity, right? How does the front end find the database, and how does the back end find the back end processing job find the databases, and where's the cache and all that sort of thing? And the solution to that in Kubernetes world is called services. So we'll overload the word again. But what a service is in Kubernetes is essentially it's a load balancer that is aware of the health of the pods. So you create the service, which automatically creates a load balancer that points at all of the active pods, no matter how many there are, and sends the traffic to the healthy pods. And so this ends up giving you a nice, clean abstraction between the different pieces of your application and the rest of the world. And so it's often kind of a design goal to have internally in your services world to actually have load balancing, but often it's a lot of work on internal networking infrastructure, and it doesn't end up happening. So you get that for free with Kubernetes, and that's super fun. So what that might look like, oh, you want to see another demo? That? Yay! Okay, so this demo I actually just fiddled with and got working during the last talk. So we'll see how things go. So we're going to kind of like fill in a database layer here. We're actually going to use Redis as a proxy for a database. So this is going to be kind of for a live chat guestbook sort of thing. So what this ends up looking like is we have some front ends that are in PHP. And each of those, so it runs like, say, 3 pods. We've got a Redis master where we're going to send all the writes. So we're going to make a connection for writes. And we've got read slaves for all the reads to go to. And so no matter how many of these we have running and in what configuration, the services can all find each other, no matter which host they're on and the like. So let's see if we can make this work. So we're just going to run a whole series of commands. Basically, and let's take a look at one of these files. But basically, we're going to run a single pod, not a replication controller based thing, just one pod for our master database, and then wrap that behind a service. We're going to run a replication controller for the read slaves and put that behind a service. And then we're going to start the actual guestbook front end, put that behind a service. So, oh, right, and let's actually look at one of these. So let's look at the Redis read stuff. So the controller is just like what we saw before. It says 2 there. It's based on a particular image, and we can send regular startup kind of commands to it. And it's exposing certain ports. And then if we look at the service configuration, it's just very, very basic. It says, it's going to be based on this port, and we're going to, use these labels in selector and expose it on this other port, which might be the same. And then what that looks like from the front end piece is pretty much the same, but with this extra line. And depending upon the environment that you're deploying this to, you can actually say, oh, hey, environment, go ahead and set up an environment level load balancer for me. And so in this case, we're running on Compute Engine, and so we can actually use Google's data center level load balancing to actually do this, send this traffic to our front end pieces. So let's see if it works. And we're just going to deploy this to the same cluster of machines that we had running before. So we're going to get a bunch of these pods coming up. And they all kind of connect to each other. And then, let's see, so we'll take one of the front end ones, grab this IP, grab it in such a way that cut and paste will work. And we can connect to this, and we have a little application, and we can say, hi. look, he can type in front of people, kind of. So we've got a real guestbook application here. But if we kind of pop over here to the, this is the Google Cloud Console. We can, let's actually make this a little bigger. We can see that we have these 5 nodes running and a master. Kind of poke in here at network load balancing, see that its IP address is this, and demogods willing, we can hit this load balanced IP, and it should be awesomely working. And there it is. Oh, and hey, look, people even notice where this is. So you got a room full of very astute and aware people. And this is the moment where I move away from this page. Thank you. Okay, so thank you all very much. And so you can just kind of keep stacking these pieces together and make new versions of things that are running in parallel with other things, and they can all find each other, and it's good to go. So we now have this distributed process manager that's we can feed things to, and it will run them, and all be awesome. So do you have to run this thing yourself? No. So as of just a week ago, we announced that we've got a hosted version of Kubernetes that's available called Container Engine. So everything's an engine on Google Cloud. And this is Google Container Engine. This is exactly the same open source code running on Compute Engine managed by Google. So it's just like running the open source version without building and running it all yourself. So if you want to play around with this, this is a very good way to get started. And it shows up in the console just right there. You can go ahead and click the button and get yourself a cluster up and running. So this gives you a cluster in, we'll say, tens of seconds, fully configured. You get to decide how big it is. It is absolutely intended. Kubernetes itself is intended to be multi-cloud. Container Engine is hosted on Google's cloud. It is open to the public right now. It is alpha. Let me just say this again. It is alpha. And not like Google style, oh, Gmail's in beta for like 3 years. It's alpha. So please absolutely give it a try. And I've got some links later for if you do run into trouble. We've got a lively and growing community, and we'll fix it. So whatever you run into, we'll make it good. And if there's use cases that it isn't currently capable of, we'll make that work too. So I also want to highlight our user experience folks have been working on things like the cloud console and all that sort of thing, and the command line tools. This link will be on a few slides as well. But if you're interested in kind of playing around with things and giving feedback, seeing some of the early stuff, please give that a go. Or if you just know how things ought to be, please let us know. Also, everybody here, and actually everybody, gets $500 in credit that lasts for 90 days. Just kind of visit this URL. My finger down here isn't going to work, is it? URL up there, enter try Kubernetes, and your credit, and you're good to go. So we also are very, very active on a mailing list called Google Containers. So it's a Google group on Twitter and on IRC. So if you jump on IRC right now, it might be a little early for some of the US folks, but a little later today, there should be tons of people on and very active. So thank you all very, very much for coming. This is really humbling, and it's super exciting to see this many people in the room to hear about this. And please give this stuff a try and let us know how it goes. So join us with Kubernetes. Thank you very much. And Q&A time. Oh, this is going to be super fun. Okay, yes, sir.
How you compare Kubernetes with Mesos and Marathon together?
Okay, how do we compare Kubernetes with Mesos and Marathon together? So this is where full honesty comes out. I sat in on the Mesos and Marathon talk yesterday, and that's everything I know about Mesos and Marathon. So I can't personally make a really super great comparison. We're trying, yeah, I'll just leave it at that. Sorry. Well, I will say this, like Mesos is far more mature, and if you're running in production like today, like you probably want to go that direction. Kubernetes is very early, and over the next few months, we're going to get more and more solid, but it's early days on Kubernetes. Other questions? Right there.
If you need to persist your data to survive your cluster going up and down a few times, what would you use?
Right. OK, so if you need to persist your data for your cluster going up and down multiple times, what do you do? So one, it's all running on the actual hosts. So you can use whatever disk storage is available to host. If you've got a SAN available, that sort of thing, awesome. And then also you can, if you're running it in cloud, you can use various cloud providers' pieces. And so Compute Engine, for example, has persistent disk as the default storage. It's very consistent I/O. It's very, very fast. Actually, if you do go to play with it, you should know that bigger disks are faster than smaller disks. So if you're going to do some perf test, look at that. But these disks are independent of the nodes, so they're essentially network-attached disks. So when you create a definition for a pod, you can specify a volume. And that volume, if cloud providers have a way of attaching a volume to their hosts, can be out off the node. So it can survive cluster restarts or pod restarts and keep things going. That's the short version. Other questions? I'm going to try one above the rail if I can see. No. Yes, sir.
How do you replicate persistent files, for example, over regions?
How do we replicate persistent files over regions, for example? Or persistence over regions in general. So definitely a Kubernetes cluster is within one region right now. And the best way to deal with file level cross-region things is to use a blob store, like cloud storage or something like that. So you've got your key value store, and you say, oh, here's the name of this, and grab the thing back. And especially if you're providing those files to end users, it's really good because wherever they are in the world, it can pull from a closer replica. And those things are independent of actual regions. Outside of that, we start to get into standard techniques. Like maybe you could end up with regular database replication, and then you have to kind of play with things there. Kubernetes supports, so all the network space within Google Cloud is a flat space, so that things can see each other from other regions directly. And so you can set up kind of two clusters, or you can set up a cluster with specific labels so that you kind of push certain pods to one side and certain pods to the other side to do your replication setup, which would be dependent on your server. Ooh, 3, 2, 1. I'm going to say maybe we bring questions up to the front, and then we'll... OK, one more question.
So you mentioned CoreOS as one of the
yes.
partners in integration. What is the integration, or how it works with CoreOS?
So CoreOS is one of the partners, one of the integrations, and the CoreOS folks have been extremely active in the Kubernetes project. A couple of different things. One, CoreOS provides a read-only operating system to run containers on. And you can run Kubernetes clusters on top of CoreOS, so you have this very clean separation between the actual kind of running dynamic part of your system and this very, very, very stable host environment. Also, they've implemented, and I apologize, I forgot the name off the top of my head, but they've implemented a network abstraction. So if you are running outside of a cloud where you don't have a software-defined network where you can say, hey, just change these routes between all these things, or just set up a load balancer, they've implemented a software version of all of those pieces. So you can actually run the same Kubernetes cluster outside of clouds using the same kind of networking abstractions. OK, so people kind of moving in and out, so I think I may call it. I will be hanging out here for a few more minutes until the next talk, and then spend the whole afternoon at the Google booth. So thank you all very, very much for your time, and have a great time at DevOps. Go build stuff.